to study centuries-old earthquakes and the geological faults that caused them. Seismologists usually dig trenches along visible fault lines, looking for sediments that show evidence of having shifted. All right, so to study these old earthquakes and the geological things that caused them, these people dig these trenches along these visible salt lines, and they're looking for sediments that show evidence of having shifted. Okay, so looking for sediment shifting on these fault lines. Cool. Using radiocarbon dating, they measure the quantity of the radioactive isotope carbon-14 present in wood or other organic materials trapped in the sediments when they shifted. And so when I read this, I'm thinking, okay, so this is what they're doing to try to look or to try to study what caused these earthquakes. And this is the way that it works. Since carbon-14 occurs naturally in organic materials and decays at a constant rate, the age of organic materials can be reconstructed from the amount of the isotope remaining in them. So at this point, I get a little bit intimidated because this is getting really sciencey and I don't understand what's going on. And so I want to slow down and make sure that I get, so they're saying, hey, this carbon-14 that's present in wood or other organic materials is trapped in those sediments that we're measuring. Cool, and it decays at a constant rate. Naturally occurs in the age of organic materials can be reconstructed from the amount of isotope remaining in them. So I guess we're going to try to build this back up to determine maybe how old they were. These data can show the location and frequency of past earthquakes and provide hints about the likelihood and location of future earthquakes. What? Okay, so I read this and I'm like, wait, how can this data, I get how this data can show the frequency of past earthquakes, but I'm curious now of how can this provide hints of the likelihood and location of future earthquakes? I'm curious. And so I'm thinking well, maybe these happen in certain areas naturally, or maybe there's some type of pattern that's happening. I don't know. I want to learn more. And so far, we want to ask ourselves, what is the purpose of this passage? What category does this fit in? Is this to persuade us? Is this a cost-benefit passage, or is this to inform us? What do you think, Lindsay?
Can you repeat that?
What do you think is the purpose of this passage? Is this to inform us? Is this to...
I think it's to inform.
To inform, I agree. What are they trying to inform us of, Lauren?
They're trying to inform us on how the seismologists study the dating, the carbon dating and how it works.
Yeah, I agree. So far, what I think this main purpose is to inform us, exactly how you said, how these seismologists, I'm sure there's a different word for it, how these seismologists are using radiocarbon to show the location and frequency of past earthquakes and to provide hints of future earthquakes. So far, sounds so good. Does everybody agree? Did everybody grab that? Excellent. All right, so I want everybody to go ahead and read this next part on their own, and then just give me a reaction once you're finished reading it, and then we'll read it together. All right. So now it says geologists Bull and Brandon. I don't read names ever on the LSAT, or I just would say WB and MB, however you do it. I don't obsess over it. Have recently developed a new method called L-metry. Once again, I don't focus on abbreviations. I don't focus on words or things that are hard for me to pronounce. I make up my own words as I go. So I'm all right, called elementary for detecting and dating past earthquakes. So all of a sudden, I want to think about how this paragraph relates to the previous paragraph. And I'm all right, so we have this old way, which I forget what it was called already. That was called, where we used radiocarbon dating. So I'm we had the old way of radiocarbon dating, but now we have these two people that developed this new way. Cool. Bull and Brandon developed the method based on the fact that large earthquakes generate numerous simultaneous rock falls in mountain ranges that are sensitive to seismic shaking. Okay, so they developed this on the fact that these numerous large earthquakes, there was this shaking that was happening. All right, instead of dating fault line sediments, elementary involves measuring the size of lichens, growing on the rocks exposed by these rock falls. So all of a sudden my head is going to like, what is this purpose? And I'm starting to switch from this being an informative passage to like that cost benefit or contrast analysis type of passage, right? Because I'm thinking we have these two different kinds, and all of a sudden I have this sentence that shows us what a difference is. So all of a sudden I'm kind of transitioning of like, ooh, we have these two methods. I wonder if which one is better. And it goes on to say, lichens, symbiotic organisms consisting of a fungus and an alga, quickly colonize newly exposed rock surfaces in the wake of rock falls. And once established, they grow rapidly flat against the rocks at a slow but constant rate for as long as 1,000 years if left undisturbed. All right, so I guess we use this lichen that whenever the rocks fall, whenever they get exposed, it starts to grow at this slow and consistent rate. Cool. One species of North American lichen, for example, spreads outward by about 9.5 millimeters each century. Hence, diameter of the largest lichen on a boulder provides direct evidence of when the boulder was dislodged and repositioned. If many rock falls over a large geographic area occur simultaneously, that pattern would imply that there had been a strong earthquake. Oh, I'm seeing this. I'm like, if there's this lot of like if there's a lot of rocks that have this similar pattern of the lichen on the rocks, and they're saying that it would have been a stronger earthquake, right? Because like more rocks were exposed. I'm like, oh, interesting. And they can tell what earthquake it was by how big that lichen is on the actual rock. So if it's like 3.5, it probably happened more recently, right? Because it's not as big as the one that's 9.5. The location of the earthquake epicenter can be determined by mapping these rockfalls since they decrease in abundance at the distance from the epicenter increases. I'm like, oh, so this is interesting. There's going to be more of these 9.5 millimeter rocks, right, that are closest to where the earthquake actually happened. And they're going to become there's going to be fewer of them as we get farther away. I'm like, cool. And so I'm asking myself, what is the purpose of this paragraph? I think the purpose of this paragraph is to introduce a new way to measure earthquakes and explain how it works. I feel like that's all we do, right? So now I'm thinking cost benefit analysis. I think we have our first way and the traditional way in paragraph 1. We have this new way in paragraph 2. I'm making a prediction. I bet in paragraph 3, they're going to tell us which way is better. I don't know if that's going to happen, but that's what I'm predicting. Oh, sorry, this paragraph actually continues. No, this is the new paragraph. Okay. So lycomentry has distinct advantages over radiocarbon dating. Oh, tell me more. So we're saying that the second option is better than the first. Radiocarbon dating is accurate only to within plus or minus 40 years because the amount of carbon-14 isotope varies naturally in the environment depending on the intensity of the radiation striking Earth's upper atmosphere. Yeah, if it can only be within 40 years, I'm like, that sounds like flaws. That would never hold up in court. Like, you trying to date this back? I'm like, that sounds like that's just an idea, a good guess. Additionally, this intensity has fluctuated greatly during the past 300 years, causing many radiocarbon datings of events during this period to be of little value. Lycometry, Bull, and Brandon claim can accurately date an earthquake to within 10 years. Okay, I'm on lycometry's side. We can date it within 10 years. That's way better than 40 years. They note, however, that using lycometry requires careful site selection and accurate collaboration of lichen growth rates, adding that this method is best used for earthquakes that occurred within the last 500 years. Okay, so they say that it's best used within the last 500 years, and we have to really understand the collaboration of lichen growth rates. And I'm curious, my curiosity is getting the best of me here, which is good, where I'm thinking, I wonder if it has anything to do with, because like the lichen grows at a constant rate for 1,000 years. So maybe like the 500 years has something to do with that. Like maybe because the rate of speed changes, so it's like slows down. So it's harder for us to determine. Sites must be selected to minimize the influence of snow avalanches and other disturbances that would affect normal lichen growth, and conditions like shade and wind that promote faster lichen growth must be factored in. So it's kind of like this equation, right? That we have to like avoid these other instances, and then we have to also be able to calculate in these natural things that might influence how fast or slow lichen grows. Cool. Did everybody read it at that level and understand it like that when you read it the first time? Do you feel like, yep, I got it, I can go in, I'm a lichen master?
No, not a master, but yes, I understood.
I know, like I love it. I'm like, so if someone like I can't wait until I'm at the brewery and someone brings up, oh, did you hear about this earthquake? I'm gonna be like, do you know how they measure earthquakes? And I'm gonna impress them with my smartness because I'm gonna be like, well, there's these two forms. And one of them is dated and it can only be within 40 years. But we have this new way called lycometry. And whenever the rocks fall, rock is exposed and lichen starts to grow. And based on that circle, and how big it is, we can determine how long ago it was and how many rocks have that same pattern is how we can determine its strength. I'm going to be so excited about it and I'm going to scare them off, but it'll be fine. That's what we want to do, right? Like we're even like, we get to be so smart. So moving on to how we are answering these questions. I love how Katie says this. RC is just sneaky LR, right? We have a lot of main point questions or main conclusion questions, and we have a lot of must be true questions. So anytime we have a question, we want to put it into like, how would we handle it for LR? And we want to predict. So for starters, we have what is the main point of this passage? And so the first thing we want to think about is what is our purpose? So what is our purpose, Jessica?
I think our purpose is to how do I put this in like simple terms? Because I tend to overcomplicate everything,
Are
but
we
like
trying to inform, persuade, or compare?
I think it's more of it went from informative, but I think it became a cost benefit because we
I would
start
agree.
to get like the pros and cons, but we ultimately know like our author is like all in for like mentry, whatever it's called.
Oh, like entry, I don't even know. I'm just calling it
Yeah,
like,
who knows? Who cares? But like we just know our author like supports this new method because it has certain advantages over using.
do we support it or do we just think it's better?
Well, I think he thinks it's better. So in my mind, I'm like, oh well, he supports the use of it over radiocarbon.
I would agree with that. Think about the political election. Some people thought one person was better than the other. They voted for him and they didn't necessarily support them, right?
Mhm.
So I think that's a little bit picky here. But keep in mind, like, just because we think, I do agree with you that we think something's better, that doesn't necessarily mean that we're all gung-ho for it. But I do think we are definitely for one over the other.
Yeah.
I'm being very nitpicky. But yes.
No, I know. I appreciate it because I'm like not.
We don't no, you're totally fine. So here, I agree. Our job is, our goal here is to inform us of how we measure or we do research on earthquakes and why this one new way is better than the old way. Do we agree that that's our main point? That's why that is what they want us to walk away knowing. All right, so everyone go ahead and answer this question and put your answer in the chat. A says, lycometry is a new method for dating past earthquakes that has advantages over radiocarbon dating. Do we like that one? I like that one so far. I definitely wouldn't cross it off. So I'm going to leave that one open. Let's go on to B. Despite its limitations, lycometry has been proven to be more accurate than any other method of discerning the dates of past earthquakes. What makes this one wrong, Lindsay?
I think it's more accurate than any other method. We only learned
Yes.
one other method.
This is why I was so picky of Jessica's comment, where we truly were just comparing the two things, right? We don't know that it's more accurate than any other method. We're just saying that it has advantages over this other thing, right? That's why this person wrote this. All right, C says, most semiologists today have rejected radiocarbon dating and are embracing lycometry as the most reliable method for studying past earthquakes. Do we know if this is happening, or do most people, even if most people have rejected radiocarbon, do they think that this new way is the most reliable? Nope. And that's definitely not why this person wrote it, right? Even if this were true, this person is really just writing this to show us why this new method has advantages over something else. D says, two geologists have revolutionized the study of past earthquakes by developing lycometry, an easily applied method of, do we know that it's easily applied? No. I think that whole equation thing, like you have to calculate in the snow and blah, 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 that doesn't sound easy to me. And then E says radiocarbon dating and unreliable tests used in dating past earthquakes can finally be abandoned now that legometry has been developed. Is our point to say like, hey, we can get rid of radiocarbon dating? Like we no longer need it. We can abandon it. No, not our point either. And so A is definitely our answer. How confident was everybody on answer choice A? Fabulous. All right. So what we're going to do for the last 15 minutes is I'm going to put you all into breakout groups and in groups of 3, and you're going to go over the rest of this passage and answer the questions together and work through it together. So this is passage or prep test 62, passage 1. So if you want to pull that up and have someone in your group share their screen if they have it. And we're going to go ahead and you'll go ahead and go through these answers in your group.